Hello, am I audible? I think my mic was mute. People did not hear maybe whatever I said. Okay. Am I audible? I didn't knew my mic was mute. Okay. We were doing the rectangular tank, right? So the long wall we have designed the long wall, the reinforcements area of steel required at the support, then at the center, then at the center, and then we have the distribution steel. So we have done for short wall we have designed. Okay, distribution steel we have done for short wall at the center, at the support we have we have determined the area of steel required. Okay, so now that was the top portion. Wait 1 minute. That was the top portion. Okay, so now the next one which we are going to do is what? The next which we are going to do is this thing. Yeah, the cantilever portion, the 1 meter cantilever portion. Right. Just give me a second. Okay. So we were doing. Okay, I think. Yeah, where is my notes? Wait, I have to show you people the downloads section. Okay. Am I sharing my screen? Okay. I'll share with you all these notes. Okay, this PDF which I have for all the notes. We were having a rectangular section. We have this, these. Okay. Now comes your this one. We have done till here the distribution steels. Now we will be doing this one. The cantilever action. For the top portion we had the continuous frame. As a continuous frame we had to design, and then we had designed that as the continuous frame. Now the with the this thing, the distribution bars, the main bars, we have designed everything. Now we have to find out the area of steel in the cantilever action along the bottom portion of the 1 meter, which is fixed at the bottom, right? And we have assumed it to be considered it to be a cantilever. So here what we'll do, that h is equal to 1 meter distance, h is equal to 1 meter distance. There what we have, we know the okay, the pressure here is how much? The pressure here is gamma w into h, gamma w into h. So gamma w we have calculated it to be 10, and h is 3.7 total, we know. Yeah, I'll not go up again. We know we have already calculated this gamma w 10. Then we have how much? 37 kilonewton per meter square is our pressure at the base. Okay, at the base the pressure is this much. That means at the bottom portion 1 meter. So the bending moment at bars will be how much? Sorry, the base, this is base, okay. Bending moment at base is equal to how much? Half into base into altitude, and since this is moment, so h by 3 is multiplied, because we know what the for a triangular section it has its what BCG at h by 3 distance, right? So bending moment at the base, the area of the triangle at the base is how much? Half into base into altitude. So the this thing, the moment is how much? Half into base into altitude. Base is gamma w into h, the pressure. Half into base into altitude is h distance, and we have the moment h by 3. So multiplied by h by 3. So we have got our bending moment at the base to be 6.16 kilonewton meter. Now the area of steel for moment, this one, area of steel for the moment is equal to given by m by sigma st into g into d. So m is, we have got our m to be how much? This one. When the moment at the base is 6.16, so that is this much, 6.16. We have already calculated the sigma st, j and d. We already know. So this is our area of steel for moment. Hmm. Okay. So what will happen? This is area, the minimum area of steel is how much? 0.24% we know. 0.24. So it is area, minimum area of steel is how much? 0.24%. So yeah, what can be the this thing? Area of steel can be how much for here? 0.24 by 100 into B into T. B into D. So that will give you 360 mm square. Okay. 1 minute. Yeah, so we have got our area of steel for moment is this much 210, but our area, this one, area of steel, minimum area of steel is how much? 360 mm square. This is less than 360 mm square. So we will provide the minimum one, this one minimum value, because this one we have got it to be less. So we'll take the minimum which is required area of steel. This minimum requirement is 360 mm square. So we'll put on each face in vertical directions. Okay. So this one is 360 mm square on each face in vertical direction. Okay, this 360 mm square area of steel at the bottom we are providing on each face in vertical direction. So on each face, that means on the outer face as well as on the this thing now. Inside the water was there, so it was a liquid phase. So area of steel is on each face we are giving in on the base 360 mm square. Okay, now we will design for the base slab. There must be in a tank, rectangular tank, there must always be a this thing also, the base slab. Okay, so the base slab is how much? The base slab design is this, which is we will provide, we are assuming and providing a 200 mm thickness of this slab. The top zone is how much? The top zone, okay, on the base slab also we will be having two zones, one at the top, one at the bottom. Okay, so that is divided by 100. That means it is divided into two portions, top zone and bottom zone on a slab. Hmm. At the top portion and at the bottom portion, so top zone is 100 mm and this is 100 mm. So minimum area of steel is how much? The minimum area of steel, we know 0.24 percentage is the minimum area of steel. So 0.24% of B into D. Depth is, we already got it to be this one, 100 mm. So B is per meter, length we have taken. So 0.24% per meter length. So 240 mm square is the minimum area of steel here on each portion, top zone and bottom zone. 100 240 mm, 240 mm square. So we will provide, so we are providing 8 mm 5 bars at 200 mm center to center. So we, right? Okay, so we have got it to be 8 mm we have considered will provide an 8 mm 5 bars at a spacing of 200 mm. So the area of steel provided will be how much? Area of steel provided is this much, 281.32 mm square. That means pi d square by 4 and d is yeah, diameter. So pi d square by 4 by 200 is spacing. Area of the ring bar. Okay. Area of the bar. Then we have the divided by the spacing. We have got the area of steel provided to be 251 mm square. Okay, now since we have designed everything, we have designed for the longer wall, for the shorter wall, at the on the center, at the support, at the base, everything we have done. So now, if I show you in a plan, this whatever you have designed till now, if I show you in a plan, let me show you. Um, it's not how. How to minimize this? I have to stop sharing, I think. Okay. Now you see here. This is after we have designed this one. I have taken a picture of this. If I rotate it, one second. Okay. So you see here. These are the plan. This is your plan. Okay. So you see here what we have got. This is the plan we have. This is the sections also is here. So we had how much on the plan? If you see, this is the this face, the liquid face. This is the outer face on this side. So we had done both. Hmm? This is the support one, 1 meter support, 1 meter support, and this is 20 mm 5 bars we have used at 130 mm center to center. Okay, these one on the liquid phase we have used 10 at the center we have used 10 mm 5 bars, 210 mm center spacing. Okay, main bars we have used this one, main bars 20 mm, 240 mm center to center. Right. Here also same. Main bars, these are the main bars. This one. Main bars which are provided is how much? 20 mm, 520 mm dia, 120 mm center to center. We have the distribution bars 10 mm at a spacing of 210 mm center to center. Okay. At these, yeah, these are your plan. The plan, whatever you have designed, you see here in the drawing, you can see here already in the plan, whatever is written. At the center, we have got this distribution bar, stand. Let me check once. Is it correctly drawn or not? If we see at the long wall, at support, we have how much? Yeah. So we have for long wall, this is the longer wall, 6 meter. 6 meter longer wall, we have how much at the support? At this support, we have provided what? We have provided the area of steel to be 20 mm dia. This one at the support, 20 mm dia. Okay, and this one 20 mm main bars of 20 mm dia bars of 120 mm center to center. This one at the supports. Okay, for longer wall, along the longer wall. Now along the longer wall only at the center, we had provided how much? The area of steel provided 20 mm. This one 20 mm 5 bars, 130 mm center to center. Okay, 130 mm center to center here. Then we have distribution steel. How much we have given? We have given distribution steels to be this one 10 mm 5 bars, 210 mm center to center. Okay, all these are whether it be on the support or on the center. Your distribution bars are of 10 mm 5 bars, 210 mm center to center. Okay. Now again coming to the shorter wall, we have what? For the shorter wall, along the shorter wall at the supports, this ones at the supports, we are having how much? We are probably have provided 20 mm 5 bars. This one main bars are 20 mm 5 bars, 120 mm center to center. Then at the center we have how much? At the center we have 16 mm dia bars of at 160 mm center to center. Okay, and the distribution bars, we know our distribution bars are 10 mm 5. Okay, we have distribution bars everywhere. It is 10 mm at the rate 210 mm center to center. Okay, then wait a 1 minute. So you see here now, if we see the section, if you see in the section, if you see here in the section, you see again you can see 20 mm, 120 mm center to center. Here we know. Okay, so these are the bars here, main bars which are provided here. You can see these are 20 mm at a distance of spacing of 120 mm. Okay, and at the base slab we have done what? On the base slab, wait, on the cantilever portion, how much we have provided? We have provided, okay, for the base slab, we have just now provided how much? The bars to be 8 mm at the center spacing of 200 mm, 8 mm diameter bars at a distance of, at a spacing of 200 mm, and we have rest are same 10 mm at 210 center to center. We have main bar. Okay, So then again this side also you will see 8 mm at the base slab, 8 mm diameter, 200 mm center to center, 16 mm at the center again. Okay, so this was your plan and section of the reinforcement or the area of steels which you have provided. Okay, you can compare if you have the notes with you. You can compare and see the diagram. You will understand it more clearly. Showing you design of short slab. We have 20 mm to 40. Okay. 20 mm, 120. Okay, this one 20 mm at a spacing of 120 mm, and we have 16 mm, this one 16 mm at the center, we have 16 mm at a spacing of 160 mm center to center. Okay, this was for a short wall. Then for long wall we have 20 mm, 130, 130, but where is 130? Yeah, 210. Okay, okay, this is 20 mm, 120 mm center to center at the supports of the long wall. So in this way you can just check the section as well as the plan which of the reinforcement which you have designed, how is it actually placed and why you are designing. You will understand then when once you compare the this thing your calculation as well as your diagram plan. Okay, so once you have this, you will have what? This one. I hope you understood now this thing. So this was your plan for your whatever you have designed for your this thing till now. The rectangular tank. Okay, at the supports, at the center. Okay, at the base. Okay, so this was your. Where is this? Okay. Okay. Is my screen visible to you all? Okay. Okay. Visible, no? So, in this way, whatever you have, calculated the area of steel, so you can plot it there on the plan and your section. Then, if okay, for circular water tanks, again we'll do we can take a problem on circular water tank again. But let me check one thing. Wait. Okay. Okay. We have one more class now at 1 p.m. I think we'll continue. Okay. I'll not take from 1 p.m. but I'll take after this class gets over. I'll take the class and I think we have a lot of class now from your according to your new academic calendar. It is still 20 January. So till 20 January, we have lots of time. and also your analysis. For the analysis, I want to give you some information about that. That the analysis will be you have two chapters left, I think, on your analysis. So that analysis AOS 3, the last chapter I am going to take, and the other one your Rudraj sir is going to take. The plastic analysis, I'm going to take that part. And let me check and tell you that according to the timetable, right? Yeah, just a minute. According to the timetable, now we are having your section A, right? For section A, okay, I'm getting one class, but in section B, yeah, two class I'm getting there for AOS. Okay, so AOS, the analysis of structure part. Will college reopen for students? Pallab Talukdar. For students, it's not yet confirmed, but those who are having projects for lab-based projects or experimental works, they can come. They are allowed to come. They are coming, and they are also asked to come. Not only allowed, but they are asked to come for their works, project works. Hmm. Once everybody is allowed to come, you will get information regarding that. But for now, only the lab based, if anybody has experiments or works to be done, they are allowed to come and they are asked to come. Okay. So this next class which we have from 1 p.m. I'll be taking after this class only, so that you people get free now, free time after this. Continue we shall do after this class. Okay. And yeah, what I was telling you. I'll take the attendance on the second class, and the same attendance I'll be giving for both the this class and that class also, okay? Or shall I take now the attendance for now also? I'll take both the attendance now. Okay then. This is section A. Section A. Section B. Section. Okay. 10, 11. Number 1. 1. Stephanie. 2. 4. 4.
Present, ma'am.
5.
Present, ma'am. Room 5.
6.
One, two, one, two, check.
7. 8. 9. 10. 11.
10 present, ma'am.
Okay, 11.
Roll number 8, present.
8. Present. Okay, 9. 11. 12. Pusho
Present,
come.
ma'am.
14.
Present, ma'am.
Sorry, 12.
Present, ma'am.
12 is present. 11 is absent, no? Okay, then 14.
14 present, ma'am.
Marco, you please mute here. 15. 17.
Yes,
17 present.
18. 19. 19. 20. 21. 23. 24. 25. 26. 27. 30.
30, ma'am,
Ma'am,
present.
ma'am.
30, 31. 32. 33, 34, 35, 36, 37,
37 present.
38,
Present, miss. 38 present.
39, 39, 42,
42 present, ma'am.
42, present, 43, 45,
Present, ma'am. 45.
48,
48 present, ma'am. 48.
49, 49,
Present, ma'am. 49.
50,
मैं बात ली थी
50, 50, 51, 52, 54,
Yes, ma'am. 52, ma'am. 52.
54,
Present, ma'am.
56, 57,
Ma'am, 52 present. 52.
yeah, 52 present, 57,
Thank you, ma'am.
okay, 57, 58, 58, 60,
60
61,
present, ma'am. 60.
61, 63,
Yes,
ni-
ma'am. 63.
99,
Yes,
hun-
ma'am. 99.
101,
Ma'am.
104, 106,
Present, ma'am. 106.
108,